Hi all, myself Nitin Jadhav. I'm a senior software engineer at Microsoft. So today I'm going to talk about leveraging the Perf tool for PostgreSQL performance optimization. So performance is a very vast topic. So I'll first start by defining what I'm going to focus in this talk, and then I'll introduce the Perf tool. And after that, I'll explain how this can be applied to the PostgreSQL performance analysis with an example. The performance analysis in PostgreSQL has multiple layers. So starting from configuration and query tuning to executor and CPU level behavior. So today I'm going to focus on the specific one. So that is how to leverage modern CPU architecture to improve the performance of PostgreSQL. So let's see the Perf tool. So the Perf is the Linux performance analysis tool used by the developers and system administrators. So with this tool, we can actually, it helps us to understand how the application is interacting with the CPU and the Linux kernel. So we can use it to diagnose the bottlenecks, I mean performance bottlenecks and the CPU behavior. So we have this perf list command, so which is used to list all the supported CPU events on the system. So this is particularly helpful on the VMs because the VMs don't support the hardware instructions, I mean hardware events. So in that case, we can run this to understand what all events are supported on the system. So when we run this with a sudo, it gives the full list. When we run this without sudo, it gives the limited set of events. So and we have this perf top. So whenever we run the normal Linux top command, so it shows the CPU behavior in terms of processes. So when we run perf top, it shows the CPU behavior in terms of functions. So we can use this to analyze how the PostgreSQL functions are behaving. And we have perf start, so which shows how the program is behaving in terms of different CPU metrics like CPU cycles, instructions, and cache misses, cache hits, and branch misses, etc. So cache misses happens when the CPU don't find the data in the CPU cache. So it is very important to understand that how exactly we store the data in the memory so that there won't be many cache misses. And also, the modern CPUs try to predict the branches in advance to keep the pipelines full. So that if the prediction is wrong, so then we call it as branch misses. So that will be a very expensive thing. So we try to minimize all these things like cache misses, branch misses in order to get the better performance. So this perf start can be run for a system-wide, as this example shows that it is running for a system-wide, and this is running for a specific command. And then we have perf record, so which is used to, like this collects all the data and stores in a file. And then we have perf report to analyze, I mean to view and analyze this file. So this is specifically useful whenever we deep dive into things, so then we can use this. So I'll quickly show these topics with two examples. So the first one, so here what I'm doing is, both of these program is doing the same thing. That is, it is calculating the sum of nodes in a linked list. So in the first program, the nodes are actually scattered in the memory. I mean, so I'm allocating the memory for each node. So the memory is scattered. So in the second one, I'm allocating memory for all the nodes at once. So if we see the perf result for these two, the second one, so we have fewer cache misses compared to the first one. It's because whenever the CPU loads the data, so it loads a chunk of data. So whatever data is required for few instructions, it is already fetching it once. So in the first program, the data is scattered across memory, so it might be like fetching the data for every instruction. So that's why the program 2 is better in terms of cache locality. And this is the second example. And again here, both of these programs are doing the same thing, calculating the sum of the array elements. So in the first one, the data is unsorted. So we have this branch wherein we are trying to compare if the data is greater than 128, then we are adding that element to the sum. So since the data is unsorted here, so the CPU can't predict this branch perfectly. So and in the second example, the data is sorted, helping the CPU to predict the branches in advance. So if you see the perf results, so the second program is better in terms of branch misses compared to the first one. Finally, I'll quickly show how this can be applied to PostgreSQL with a simple example, which was done in PG18, I think. So here, the exec scan function, which is the core function which gets executed for every row written by the select query. So there were few conditions in this function. So that is, it was checking for qualification and projection infos were present or not. So for most of the SQL, just one. So for the most of the SQL queries, so we won't be having qual and projection info. So this was getting unnecessarily. So the fix was done they separated into different functions, so that whenever this was not present in the query, so these functions won't get executed. So similarly, the perf output shows that after the fix, everything was better. There were fewer cycles, CPU cycles, and fewer instructions, and better in terms of cache misses and branch misses. And finally, before the exec scan was taking 5% of the CPU, and after that, so this was not present in the top usage of the CPU. That's all I wanted to cover. Thank you.